Okay, in this video we're going to talk about the relationship between slopes of a linear equation and the rate of change, the concept called a rate of change. And we're going to bring in some other concepts as well, like functions and that sort of thing. So let's get right down to it. We're basically talking about a linear equation, and we know that when we describe a linear equation or any line that goes through a series of points, that particular line can be described in a number of ways, right? Here's my x-axis, here's my y-axis. Let me just write that in there real quickly. This line can be described a number of ways, right? We know that, for example, any point on this line is composed of an x and a y coordinate, right? So, for example, if this was like 1, 0, 1 along the x, 0 along the y, this point would be 1, 0. We know if we have another point, let's call this one 0 along the x, -1 along the y, that would be the point there. If I wanted to describe the slope of this line, because any two points, when you draw a line through them and extend them onto infinity, that defines a line, right? So any 2 points define a line. And that's an important concept to know. Any 2 points define a line. And from 2 points, you can derive equations and slopes for that particular line. You can describe it. Now, the slope of this particular equation is written like this. M, which means slope in the algebraic language, is equal to the difference, and that's that little Greek symbol. It looks like a little triangle. It's called the delta. The difference between the y components of the 2 points that you're looking at and the difference between the x components of the 2 different points that you're looking at. Another way to write that is to say like y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, what do these little numbers down here mean? Basically, it's just trying to keep track of which of these points you're looking at. So, for example, the x2 and the y2 have to be together. The x1 and the y1 have to be together. If we wanted to figure out the slope of this line that we drew here, we would just substitute numbers. So let's say y2, let's just call this one the 2. So it's -1 minus 0 over x2 would be 0 here minus 1. And when we do our math, -1 over -1 gives me a slope of +1. So m here is equal to +1. This slope is also called a rate of change. Now let me connect those for you. This is basically saying as x increases 1, y increases 1. Let's just start right here. So if I increase 1 for the x, that means that my y increases 1 as well. So you just put the y over the x, divide, and you'll get 1. So any of those numbers would work. So for example, if I said that my x increases by 5, what would be the increase of the y? Well, since I know that the slope is 1, I would say 1 is equal to, and let me just make this in the form of a question. If m equals 1. So I know that m is equal to the change in y over the change in x. Let's just substitute what we know. We know that m is 1. We know that my x is 5. It increased 5. So therefore, what would be my y? You could solve that. We'll make that step 1, step 2. If you went ahead and solve that, multiply both sides by 5, and you end up with 5 is equal to y. So you could say, for example, again, that according to this equation, with a slope of 1, if my x increased by 5, what would my y increase? Plug it into the equation, and you would get your y. Okay. Now this is also known as something called a function. A function is basically based on something called inputs and outputs. Inputs, outputs. Okay? And I want you to watch the next video to figure out how this is related to the slope and to the rate of change. Okay? I hope that was helpful.